Hello everyone, in this video we're going to learn how to prove this trigonometric power series formula. This formula was used to calculate the sum of this series in the last video. Please check out the link in the description below for this video. Now, in order to prove this formula, I'm going to use information right here. First, I'm going to talk about the geometry series. Alright, the series r to the k equals r over 1 minus r with absolute value of r less than 1. You have the Euler's formulas. E to the I theta equals cosine theta plus I sine theta. Similarly, if you have the negative side right here, it should be negative side right here, right? And then you know that the cosine function is even, so cosine of negative theta equals cosine theta. The sine function is odd, then sine of negative theta equals negative sine theta, right? So that's why you have this one, right? Now, if you have a complex number z equal a plus bi, then the modulo of this complex number is square root of a squared plus b squared. Similarly, now I'm going to apply this formula right here for this one right here. Right? So I have the modulo of e to the I theta. It could be square root of cosine square theta plus sine square theta, and it's actually 1, right? Now I'm going to let this one be s, right? This is the sum. We're going to consider the related complex geometry series C. It's going to be, now I'm going to expand this series using the formula right here. So it's going to be, now note that S right here actually the imaginary part of this series, right? So S equals imaginary part of C, right? Now since absolute value are always less than 1 because given right here, right? And the modulo of e to the I theta equals 1, which is right here, right? So it tells us that the absolute value of common ratio, which is this guy right here, right? Less than 1. So we're going to apply the geometry series formula right here, right? When absolute value of common ratio less than 1, it's going to be this guy, right? So now we're going to rationalize the denominator. Now I'm going to calculate the numerator first. Distribute this one is going to be r e to the I theta minus r squared e to the I theta times e to the negative I theta, right? So it could be r e to the I theta minus r squared. You're going to add the exponent, it's going to be 1, right? Now, e to the I theta equals this guy, right? So I just replace this guy with this guy, right? So it's going to be, we're going to deal with the denominator. I'm going to distribute this guy, right? So it's going to be 1 minus r e to the negative I theta minus r e to the I theta, right? Plus r squared e to the I theta times e to the negative I theta, right? Now we're going to factor negative r out, right? So we're going to end up with this guy right here plus this guy, right? So it's going to be right here. If we add this guy and this guy, does that mean we're going to add this guy and this guy, right? And this guy cancel out. So we have 2 cosine theta, right? So it's going to be 1 minus 2 r cosine theta, right? And this guy right here equals 1, right? So it could be, so finally C equals, the numerator is right here, denominator is right here. Now we need to solve for this guy, right? So we're gonna take the imaginary part of C, right? So which is this guy right here, right? It's gonna be exactly this one right here. For absolute value of R less than 1, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us high.